Class example 4.45. Given the graph of the functions y is equal to f of x and y is equal to g of x below, determine an equation for each function in both factored and expanded form, and then determine the range of each function. So first I'd like to explain what it is that we're looking at here. So this doesn't look like a rational function like we're used to seeing. It looks like a linear function. And that's because it's already been simplified. We can see that there was a point of discontinuity at x is equal to -3. So that means that something must have canceled there. So let's try just writing in what it is that we know. So let's say f of x is equal to, and then I'm going to split this up between the numerator and the denominator. And then I'm going to focus on this point of discontinuity first. So if there's a point of discontinuity at x is equal to -3, then there must have been a factor of x plus 3 in the numerator and in the denominator because they canceled, right? Next, I have a x-intercept at -1, which means that I would have a factor of x plus 1 in the numerator. All right. Now, the next thing you'd want to do is look down to the denominator and see, do we have any vertical asymptotes? Because those would also be included in the denominator, but we don't. So that's pretty much it. Other than we don't know what the value of a is. We don't know what our stretch factor is. So like the other class examples, we are going to solve for a by substituting in a point. So let's use the point that was given, even though we could use, let's say, this point. It doesn't really matter, but I like this one because x is 0 and zeros make things nice. So we're going to use this one with an x and a y. So this would become -4 is equal to a times 0 plus 3 times 0 plus 1 over 0 plus 3. So this becomes -4 is equal to 3a over 3, and those 3's cancel. So we get a is equal to -4. All right, so now we'll just throw that -4 back in for a. So we'll have f of x is equal to -4 times x plus 3 times x plus 1 over x plus 3. And there we go. There is our original function before it was simplified. Next, we want to write this in expanded form. All right, so the last few times I expanded this out, I expanded the 4 into the first bracket. This time I'm going to expand out these two factors, x plus 3 and x plus 1, and then expand the -4 into that, just to change it up. So we'll have f of x is equal to, and then the -4 just hangs out for a second, and then we'd have x squared plus 4x plus 3 over x plus 3, and then f of x is equal to -4x squared minus 16x minus 12, all over x plus 3. So now there's our expanded version. Part 2 says determine the range of each function. Okay, so what are the values of y that are not allowed in our range? Well, it looks like it's only going to be the y value of the point of discontinuity. So how do we find that? Well, we're going to throw our non-permissible value back into the simplified version of the function. So we haven't actually made a simplified version of this function yet, but it should be pretty easy from this step. We can actually just cancel our x plus 3's. So our simplified version would become f of x is equal to -4 times x plus 1. And that's it. So now from there, we're going to substitute in our non-permissible value of -3. So f of -3 is equal to -4 times -3 plus 1 So f of negative 3 is equal to negative 4 times negative 2, which is equal to 8, which makes sense. We could actually see that from the graph, but it's good that we did this for good measure. So then we know that this point here is at negative 3, comma 8. So if we're creating the range for this graph, we would say the range will be y such that y cannot equal 8.